All right, what up, everybody? This is Mr. Stan coming at you with another physics video. This time we're talking about how to look at a velocity versus time graph and kind of translate it into a position versus time graph. So we're going to look at a graph that tells us how fast something's going and be able to figure out where something is. Okay, so when we do this, we need to understand what different parts, what different shapes of a velocity graph mean. So first of all, you look at where the line is on a velocity graph, can tell you important information. If it's on the top half, right? So if you look at the velocity graph here on the top half, then the velocity is positive. If the line is on the bottom half, velocity is negative. Now, it also matters how close to that middle line the graph line is. So remember, right at the middle line, the velocity is zero. All right, and so it's completely stopped, which means that when the line is close to the middle line, the object is moving slow. But if it's far away, and it doesn't matter if it's far away at the top or far away at the bottom, the object is going to be moving fast. Okay, so looking at the velocity graph, just by looking at where the line is, you can tell whether it's a positive velocity or negative velocity, and you can also tell whether it's fast or slow by whether it's close to the middle line or far away, right? And then you can tell the acceleration looking at a velocity graph by looking at the slope. The slope of the line is equal to the acceleration. So if the line is sloping if it's going uphill, when you look at it from left to right, that means there must be a positive acceleration. And then if it's going downhill from left to right, there must be a negative acceleration. A flat line that's neither going up or down means that there's no acceleration, okay? Which again doesn't mean that the object's not moving, but if it is moving, it's moving at a constant velocity, okay? And it depends on where on the velocity graph that line is as to what that velocity is. So you find that information by looking at the velocity graph, and then you use some attributes of a position graph to figure out what the position graph would look like. So once you find the velocity, which you find by looking at where the line is on the velocity graph, then that velocity will tell you the slope of the position graph, okay? So if you have a velocity that is up in the positive and it's way up in the positive, so it's fast and positive, then you would expect the position graph to have a line that was going up because it's positive, and also going up steeply because it's fast. So the velocity is far from zero, right? Also, you take a look at your acceleration that you find from the velocity graph by looking at the slope. And then when you translate that to a position graph, that's going to tell you whether it curls up for a positive acceleration or curls down for a negative acceleration. So for instance, if you see a negative slope on the velocity graph, that tells you that the position graph is going to be curling down. So the graph is going to look like some part of this curl down shape. Okay, so let's look at a couple of examples. Here's a velocity graph, right? And we're try to figure out what the position graph would look like. So we're going to ask ourselves a few questions. First of all, is the velocity negative or positive? And you can see that this line is all in the bottom half of the graph, right? So it's all negative because it never crosses this the zero line. Okay, so this is definitely negative velocity, which means on the position graph, the line of the graph is going to be moving towards the reference point. So it's going to be going down. The line will be going down towards the zero line at the bottom. Another thing we notice about this velocity graph is that the slope is sloping up. Okay, so even though it's a negative velocity, the line is sloping up, which means you must have a positive acceleration. So somehow this position graph is going to be moving towards the zero line while it's curling up. Okay, and it is possible to have a negative velocity and positive acceleration, and we'll see what that looks like in just a second. Also notice that velocity moves towards zero. Okay, how do we know that? Because you notice if you read this graph from left to right, the velocity starts off way down here, away from the zero line, and as the time goes on, it gets closer and closer to zero. And actually, it looks like it touches zero, which means the object eventually comes to a stop. So what would that look like on the position graph? When the velocity is far from zero, the line on the position graph is going to be steep. And then when the velocity gets to zero on the velocity graph, on the position graph, the line will be flat. Right, so we want a shape of a line here that's going to be moving towards the bottom. It's going to curl upward, and it's going to start steep and end flat. Right, so there's an example of a position graph that does just that. All right, so pause the video if you need to and see if you can figure out that example. And we'll go on to one more example. Right, this time the velocity is negative because it's all in the bottom half. But this time, unlike last time, it's sloping down. Okay, it means you must have a negative acceleration. So this position graph is going to has a line moving towards the bottom because it's negative velocity, but also curling down, not up. Okay, and one last thing is looking at what the velocity does, how it changes, and it changes from being close to zero to being far from zero. So it's going to start slow and end fast. And so on the position graph, the line's going to start flat, but it's going to end steep. So we want a line that starts out flat, moves towards the bottom, and curls down as it does. Okay, so our position graph would look like this. All right, so that's how you go from a velocity graph to a position graph, at least without numbers. You would just use these attributes of the graph. All right, and I'll see you all in the next video.